is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
Here you can see that I'm connecting the 2 points or plots with a line segment. I will do that with all 4 sides to make an even square. Make sure it is a segment rather than a ray or line, because then you will not be able to measure the length for the perimeter of the square. Now I will measure each length, and for a square the perimeter should have the same side lengths, so each side length should be the same. As you can tell in the top left corner, each side length is the same right now. This meaning it is a square, because all 4 sides are the same. Here is the equations of the line for finding the length of each line. Here is finding the area of a square. The area of a square, you will find it by length times width. So you take 5 by 5 and it should be 25 units squared, as you can see in the top left corner.
Just did your job. No, it wasn't just my job.
This is the analytical work of parallel lines. This is going to find the slope of each line to make sure that they are parallel. A parallel line would have the same slope. As you can tell here, 2 points or 2 lines have the same slope, meaning they're parallel. Here I will show you that they are parallel. I'm connecting the 2 points, but rather than making a segment, I'm going to make a line. This will extend it on forever so you can tell if it is parallel for sure. With these 2 lines plotted now, you can tell that they do not connect at either ends. When I scroll to the left and scroll to the right, there's no point where they touch. Now connecting the other 2 lines to prove to you that they are parallel in a visual form, you can tell that they are parallel indeed. Scrolling both up and down, you can tell that the lines do not intersect at any point, thus meaning that they have 2 parallel lines, meaning yes, it is a square. On a square, all angles should be at 90 degrees. I will prove to you that in this square they are. First of all, you can tell here when you click on 3 points and then you push measure angle, and the angle that will show up is the angle that is in the middle. So for this one, C will be the angle that is measured. As you can tell, it is also 90 degrees. You can also tell when it's 90 degrees because each line in this square is a right bisector. You can tell by the slopes here in the bottom left corner because there are opposite slopes, this meaning that they are right bisectors, and a right bisector always sits at a 90-degree angle. When the squares' angles are all added up, it adds up to 360 degrees, and this meaning it is definitely a square. This is a diagonal of the square. It's cut right down the middle of the square. As you can tell, it makes two isosceles triangles, meaning that two of the sides are equal. To find the length of this diagonal, you will use 5x to the square root of 2, which should equal 7.7. I will do it to the opposite two corners, and it should be the same, using the same formula. 5x to the square root of 2 should equal 7.7. We use the 5 because that is the length of the regular line. You can tell here that it does equal 7.7. Now that we broke up the square into 4 isosceles triangles, we could try to find the area in each of those triangles. So we're going to click on each side and then to measure the area. I changed them all different colors so it doesn't get so confusing. You can tell that their area in the top left corner is all the same, this meaning it is 1/4 of the square. If you were wanting to find the side lengths, you could use sine, cos, and tan, but for now we're finding the area.
Now let's sketch graphs.
As you can tell here, it's all the analytical work for finding a midpoint. There's the equations of each line or each point here that will find the midpoints for BC, AB, DC, and AD. Here you're going to find each midpoint, which we found in the analytical work in the last slide. And then you're going to connect each midpoint. These also could be the right bisectors of each line. So you'll connect them and make them segments. And we can tell that if there were right bisectors, that they are because they cross right in center point of the middle. So you found the center of the square as well. Now what you could do is find the slope of each line and then use substitution elimination to see if they are correct. Here I can now find, since I broke it up into fourths, there's 4 squares inside of the square, and we'll see if they are squares, to see if each one has the right properties. For here we found the area of each square, so you can tell that each one of them are going to be the same. Now if in the little square I could do again make it 2 isosceles triangles. Another thing here is if you added 6.25 4 times, as there is 4 mini squares, it would equal 25, which is the original area of the square. Here's some cool tricks. Using the midpoints again, connect them diagonally. When this is completed, you'll see that there's a new square. It almost looks like a diamond, just tilted. This means that all the same principles apply for this new square. It has the same lengths, not as a regular square, but has that in that square alone it has same lengths, same angles, which are right angles because it is a square. The colors are changing just so you can tell it's different lines than the ones from on the outside. Now what you can do is connect those two midpoints, and then you'd have two large isosceles triangles and four smaller isosceles triangles on the outside. You can tell here when that happens. Right now we're just making sure that this is an actual square, meaning that all the side lengths would be the same. Here you can tell in the top left corner they are. Now, connecting the two midpoints, like I said earlier, and making two large isosceles triangles and four smaller isosceles triangles. You can then again connect those two midpoints, have 8 small triangles in one square.
Listen up, all you square pegs. I got a math rap I gotta do. It won't take long to sing my song. You know I wrote it just for you. Squares are simple shapes. 4 sides all the same. Squares are functional, more than some math game. Squares are really cool, not just geometry. Squares, they work for you. Take a look and see. Squares, squares, everywhere, on the ground, in the air. Squares, everywhere.
Thanks for watching!